Hi everyone, welcome back to the third day of TechDebt. I hope you enjoyed the first two. If you're back, it means that you probably did. Today we have a great keynote, Markus Ciolkowski. Hi Markus. Markus is a lead IT consultant and head of division at QAware since 2011. This is a company, an independent company, which is based in Munich, in Germany. It analyzes, renovates, invents, and implements software for larger companies or large companies or other companies that they have software-intensive systems. Markus has quite a lot of experience as project lead, a domain architect, especially in the telecommunication and automotive domains. He has been project manager also and research lead for several research projects. Markus, I've seen a lot of technical debt, I think, at least from what I understood. In fact, he deals mostly with software quality, developers' productivity, so technical debt, agile development, they're all topics that are at heart for Markus. Also, Markus it's a great keynote, a great speaker, so I will just shut up now and leave the floor to you, Markus. And thanks again for the keynote.
Thank you. No pressure, I know. Thank you for the great introduction, Antonio. I just stopped my timer, so I won't exceed my time. Yes, welcome to my keynote. I made up a title that I now have to meet up to the standards. That's probably not as easy, but I'll try my very best. Yes, Antonia, this saves me, your introduction saves me probably my first slide. As you said, as Antonia said, we do a lot in inventing innovation in large companies like BMW, Deutsche Telekom, insurance companies, mostly the innovation projects or the renovation projects. And I show this because I would say we're kind of obsessed with quality and productivity. QAware stands for quality and agility. Basically, that's what we mean with quality and agility, productivity and quality, because this in the long run is, in our experience, that what keeps you with the customers and keeps your customers happy. We don't sell software products, but we develop software for our customers. So that's the setting. I will first talk about the context. Why did I come up with that title, The Product Owner Disappeared? Then I will share some of our practices that we collected in these type of contexts. And recently, we did a survey of a technical debt in one example project. That's an opportunity we grabbed, and I will show you some insight into that. But now first for the context. It's probably very specific to the company that we work for, and I'm sure that no one else has made any of these experiences. First, let's meet the boss of our product owner, because I mean that's very specific in that company. They have switched to Agile. Nowadays, everyone has switched to Agile. You have to, otherwise you're a bit lagging behind. But the reason they do that, or they do Agile because they do Scrum, right? Or less, or Safe, or whatever framework you pick. Typically, you send a set of Scrum Masters to a 5-day or 3-day training course, and they come back, know everything about how you do Agile. But yes, that's how it works. And of course, they have specific reasons for doing that, and they want to increase speed to market. They want to increase business value of the things that they build. And well, the third, project success rate rises because you aim at building the right thing for the users, and that's why you involve the users. And of course, customer satisfaction, that's the most important part of it, isn't it? And if they had good consultants, they know that, okay, maybe the cost will be a bit higher than with traditional projects, but you get all these benefits. And of course, Agile has a great benefit of you don't have to plan, right? Because you can change anything at any time. All you have to do is a bit prioritization and you're done. And of course, you're modern. Maybe today it's not that modern anymore, but hey, still, I'm the one who innovates. And the next thing that really is there already is they do DevOps. And they also have good reasons for doing DevOps. Speed to market, of course, will be increased a bit more than before. Business value, another opportunity with A/B tests and everything. Innovation, you can go to the cloud, migrate there, you can boost your performance, great stuff. And of course, you will raise your customer satisfaction, won't you? That's the main reason for doing things anyway. The best thing is, now you have developers who do the operations. You don't need the ops people anymore. You get 24/7 support for free. Isn't that good? And you're innovative. So the boss is quite happy with all that. And now let's meet the product owner. The boss made some commitments, and of course the product owner has to meet these commitments. Like, in the end of this year, there's this legal requirement, and we have to meet this, right? Or we promise to the US market that we'll have this great feature. You're going to do that. The problem is he doesn't really have control over the project, or she, because with agile processes, it's a bit mean in a way, because you know what you pay, it's the team, but you don't know what you get, because it's up to you as a product owner to prioritize the right things, to make sure that they are done, but you don't decide when they are going to be finished, because it's the team who does the commitment. All the product owner can do is he prioritizes and, well, can do the most important parts of the more important user stories up to the front. But other than that, does he know when the story will be finished, when the feature will be done? And then the team comes and tells him about removing technical debt. The good part is that with agile processes, all the Scrum Masters have heard about refactoring and continuous refactoring. And of course, it's obvious that you have to do that. And the product owner trusts the team, maybe. In our case, there's a lot of trust, so that's not the problem. The problem is they have to meet the boss's commitments. And it doesn't matter how much technical debt there is. And the problem with technical debt, in long term, you will have to pay it back, or you have a lot of interest, but the product owner may not be there anymore, because, at least in the environment that we have, and probably nowhere else, product owners keep moving to other projects after some years. So what you have with technical debt, or the risk that you have, is that the technical debt is a kind of SEP. You mean, what is an SEP? You know what SEP is. It's somebody else's problem. You've all read probably Douglas Adams, right? So an SEP is something you can't see, you don't see, your brain doesn't let us see, because it's someone else's problem. And it's a very powerful invisibility field. Things disappear by magic if they are someone else's problem. So the challenge we have is we want to avoid broken windows, because that is how you keep technical debt small. But when the product owner disappears, there's special challenges, because they are more concerned about meeting their boss's commitments, probably, than prioritizing technical debt, because no one will gratify them. No one will pay them a bonus for that, especially if they move away to different projects after some years. So this is a bit what I want to talk about, how in our context we manage to do that. So at least for the next part. And a bit more about the setting. We used to have agile fixed price contracts. I know it's a contradiction, but that's how it worked. We had a project where we had the development over several years, since 2012. We're still running. The program size at that time was about 150 persons. Our team was in the peak like 25 persons. Since beginning of last year, we have now 5 teams, 5 projects, and about 65, 70 persons, depending on how you count. Beginning of 2020 was also when we shifted to DevOps. So the project mode is basically agile. But surrounding the project is the traditional non-agile thinking, I would say. I mean, just imagine the traditional test and verification department. They haven't really embraced agile yet. So this is a bit the challenge, and especially the bosses, commitments long-term. It's not agile thinking, but that's life. So what are our best practices? Or I tried to condense some of them for this purpose. And one of the most important thing is to allow your product owner to plan, because they have to. And what we found helps is that you have planning on different levels or tiers. You have a long-term vision that may be several years, annual release for the upcoming releases, and for the upcoming sprints. And if you have such a planning, then your product owner can get the impression or a good gut feeling of how realistic it is to meet the commitments. So for example, if you have the next 3 releases in a rough estimation, the farther you get into the future, the more rough your estimate is. What we do is based on person days. You could do story points, doesn't matter. For us, person days works fine. It's just the most precise planning, because if you know that you will have 15 people in the next release, you know how many person days you can do, and you can counter that with a number of person days required for a certain feature. And it's approximate for the next or the upcoming release. Can be even a range, like between 150 and 300 story points. But even that rough estimate helps your product owner to be able to balance and to say, okay, we have to scope this, or we have to shift this requirement into the future because we can't really meet it. And not just, oh, we don't do it because in the next sprint we don't get it prioritized. For the upcoming sprints, you have a more precise planning, because by then you have a good understanding of the requirements, technical and business requirements that you have to meet. Of course, with the farther you are in the future, the less stable you are. But you are less stable because you can start shifting things around. And this is a very powerful tool for your product owner. And it helps him build trust into the next sprints, because this is the basis for moving and talking about technical debt. The second thing that is critical is to make quality a first-level citizen, let's say, in the project. There are some things that you shouldn't talk about and you shouldn't discuss. What we do is we have a lot of measurement like SonarQube, OWASP, security checker, and we have a zero violation policy, which means any violation that we have needs to be fixed until the end of sprint release, whatever your unit is. And that's important to not have broken windows. Zero violation can, of course, mean if you have like a legacy project, it can mean that you don't introduce new violations and start taking down the old ones. But in our cases, we try to really have a zero violation. And this is how it looked like in the project I was talking about earlier. We started in 2012. And typical course, you had a lot of violations, and then they start building up over time. Then here you have a peak. I don't remember why exactly it was so high at that point, but that was the point when we said, okay, now we enforce the zero violation rule. And that brought it down within 2 releases to 0. Of course, within a sprint, it's allowed to go up. So you have 1 or 2 violations, but then it goes down again, which is, from a research point, a bit of a problem, because if you always have 0 violations, everything you will correlate with 0 won't tell you anything. So you can't do many analysis. But from a business or from a project viewpoint, that's exactly what you need to do. You don't have broken windows. You will be able to run your project smoothly. And from this clean desk or clean workshop, you can start talking about technical debt. So the point is, try to not get into the situation where you negotiate about quality. I know it's difficult, but we managed in most cases quite well. Any system requires phases where you don't build so many new features, but solidify the system. You can have like quality sprints or bug hunting days. That works most of the time. And I talk about best practices, and I don't say we don't do that in all of our projects, right? But we've found this works, and in the long run, you need things like that. But what we do, and that works quite well, is we build into our definition of done this zero violation strategy. So and that is no problem to discuss with Scrum Masters or product owners, because it's widely accepted nowadays. 5 years ago, 10 years ago, that was different, but today it's not a problem. It's really accepted. So that's the easy part. It gets a bit more tricky if you talk about refactoring backlogs, because what we also do is we keep a refactoring backlog. That's a prioritized list of technical debt items. These items come either from the team or from the architect. Can be technical, can be requirements, usability. Each of these items has an estimation of the principal. So then you can start within the team, you can prioritize which one gives you best price value ratio. And of course, the architect will have to negotiate that with the product manager and with the product owner to a certain degree. But negotiating or trading technical debt items against features is something we try to avoid. Most of the time it works. So you don't negotiate, which doesn't mean that you are secretive or you do forbidden things. You can talk to the product owner and be open. Say, okay, when we attack or when we do this user story, we will also remove a certain amount of technical debt. What the product owners are usually worried about is if their bosses see that the team is removing technical debt instead of building this feature that needs to be done by the end of the year, then there may be discussion that you don't want to have. So if you can help it, try not to negotiate. And that works quite well, especially for small items. You can do the Pathfinder principle. Every time you touch a part of the system, you do a bit of refactoring. And you increase the user story in advance, because you know that's the part of refactoring you're going to do with that user story. For medium-sized items, it's a bit more difficult. Sometimes you do Pathfinder principle, but let's say several times, not at once, but in 3 or 4 or 5 passes. If it's a bit larger, what I think what really needs to be done is you have to have a fixed amount of quality budget per sprint or per release for doing these refactorings, so that you can rid off these medium-sized items. That's a pendulum that swings. In our case, in the last 2 years ago, 3 years ago, we had a lot of planning. We had like 10% of fixed amount per release for doing refactorings. Since last year, the pendulum swung to the other way, so they didn't want to plan anymore. And you couldn't really reserve a certain amount of budget for refactorings, partially also because of Corona. There were budget cuts, you probably all know that. And now the pendulum swings back a bit again, because they realize at least they need to have some planning, because there are all these commitments by the end of the year, legal requirements that have to be done. It's a bit difficult if all you can do is prioritize the most important user stories or epics. And then you have large technical debt items that are huge, or at least too large to do, let's say, behind the scenes. But they are sometimes so large that they are critical, like a major upgrade of a database, or you lose support, security problems if you don't upgrade. Then then your product owner will be able to prioritize it. And sometimes it helps that if you don't do it immediately, you can still have like a goal, a target picture, diagram where you want to move with your system. And then by a kind of pathfinder principle, you do small chunks every time you touch a certain part of the system. For example, we did that with UI refactoring that we had in that system. That was much too large to do in one release. So the product owner couldn't prioritize it. And then within the following year, we just did small steps every time we worked at the UI. And after that year, it was small enough to do in one release, and the product owner was able to prioritize that. This process works quite well with the technical debt, things that are not really visible outside. As soon as it's visible, other people in the project or around will notice probably. And then it's sometimes a bit more discussion involved that the product owner probably doesn't want to have. So if you go to requirements level or to the domain level, like unfinished features, that you have assumptions of use cases that are not realistic or even wrong, usability problems. Every time you touch something about that, someone will notice. And if it's only the testing department, and then you will have a huge discussion in the whole program. Difficult. But we found that these are the type of problems that really bite your behind, that really where you really have problems in the long run, that you tend to accumulate until a point in time where really you do have problems, or especially your users have problems. Domain level, what do I mean by that? I don't have a good definition. I know in my previous life, I was a researcher and I wouldn't have accepted that as a definition, but just for the idea, everything where you need to have domain knowledge to detect it or to fix it. Typically, that's a misrepresentation of the application domain by the system. And it happens very often that people have wrong assumptions or wrong knowledge about the system or about the domain when they start building a system. So the solution may be perfect. You look at the code quality, the architecture, the design, wonderful, but it doesn't reflect the processes or the use cases that the people really do. Or the domain, the organization structure, Conway's law. Yes, so the system should reflect your organization structure. It doesn't. People have to work around to work with the system, and that's another problem, you could say, because first of all, you need to know domain knowledge, and second is it's expensive usually, because you have cross-cutting requirements. It usually spreads across the system. And to clean up, it usually or often involves many stakeholders. So it's expensive to remove. And it takes a long time because you have to talk to all these different stakeholders. Sometimes the system has to be restructured. Not all of domain debt level things are like that, but some of them are. And the interest, that's an interesting thing, is who pays for the interest? It's often the users. Sometimes business value is reduced, but usually what I find is the users pay with their time and with inefficient processes. And that's something that probably wouldn't show up with any product owner because it's not on their budget. Right? Someone else's problem in a way, especially if you don't sell software as a product. Or it affects development and maintenance. Especially you could have a high amount of investment for hardware because your system doesn't run very well. Simple example, in our project, we had a business object that was termed repair scope. Then it was renamed maintenance overview. And then it was renamed to maintenance. We changed that in the UI, but we didn't change it in the code or in the database because at that point in time, it was deemed to be too expensive. But you could say it's not really a problem, is it? But the principle is, the principle in that case is you would have to rename, of course, in code. Refactoring database is always a bit more difficult. Or you could do a clear documentation. At any point where you have these terms, you could have a documentation that says, oh, really, this is repair scope and maintenance is the same. And we renamed it for this and this reason. It's not really a technical problem, but it's confusing. And the interest it causes is everyone who is new on the project will stumble upon the same thing. They will ask, oh, what's that? And probably even they will fix things and introduce errors for that. A small example. And the question we were asking ourselves is, okay, how frequent is that type of problem if you have a typical list of technical debt items? And that's the opportunity we had last year with transition of a project. So we took over a project from a previous supplier beginning of last year. In the initial phase, we did a survey of the status of documentation of code. Basically, we derived a list of technical debt items. It's superficial because we didn't have that much time. We didn't dig too deep, but we looked at everything. So you could say the scope is broad and complete, but it's still not a complete list. But we are 4 experienced architects who looked at the system. We came up with a list of 94 items. And the items are very diverse in their size. So there's a tiny one that says, oh, there are passwords, clear text in the documentation should be removed. There's another item that says, oh, there are 715 SONA violations. And also the rule set they use is deprecated, and they have reduced it a bit too much. And another item was, yes, there are 78 documentation deficiencies. Some documents are missing, some are hopelessly outdated. So you get an idea of how this list looked like. All in all, because these items are so broad, they don't necessarily fall into one type of technical debt, obviously. So they can have more than one technical debt type. But if you look at distributions, you see a lot of the structural, that's design architecture. Environmental, like build processes, infrastructure. But other than that, it's more or less evenly distributed. The size of the principle, we estimated that from very high to very low. What you see is very low doesn't exist mainly. Only one, this is the password. Other than that, you have a bit tendency towards high and medium sized items. Interest, basically the same, no very low, but otherwise not really extraordinary. But we have effort data, because since last year, since beginning of the transition, or from the point we took over the project, we have user stories that describe all the effort we put into that system. So each user story has a story point estimation, which is roughly approximate or proportional to effort in person days. So that's a lot of data. What we don't have, of course, is time to analyze. So this is just a preliminary insight, and just I pick one example. An example I pick is crawling. It's a bit interesting because the system didn't have protection against crawling when they created it. I think this is because it's a system that is meant for searching repair parts for a vehicle, right? And the previous system that they renovated was built for a decentral application. So in the workshops, the application runs and is used. They made the decision to move it to a central application only, and basically left all the architecture, all the design decisions as they were. It's the easier way, right? And it's a bit less expensive. So I guess the reason is we have always done it like that, so it can't hurt. Now the architecture is you have a UI that calls a lot of REST services in the backend, which is a standard architecture. There are about 25 to 35 million requests per day to the REST services, not to the UI. So that's a lot of load, but not excessive. What they probably overlooked is that this information, which part, repair part, is valid for which vehicle, is something that is a very valuable information in the world outside. You have some top users, I call them crawlers, that do about 5,000 to 10,000 in the normal case, sometimes up to 100,000 requests for in 25 hours. Compared to 35 millions, is not that much, but they're using the expensive calls. Because like get prices for parts, get the parts, get the vehicle data. And actually we found that some part resellers had built their own website, and you could trace the calls to our logging system. So every time you enter the vehicle there, it would show up in our monitoring. So obviously a crawling thing, because these kind of calls couldn't be caused by normal system usage. And the problem is not only that they get information for free and sell them, the problem is you get a lot of false alarms and system outages because a lot of these, or some of these calls are erroneous. So for example, in May last year, we had an incident with a monitoring alarm. The threshold for failed requests were exceeded. We looked into that. It was quite expensive, I would say, like 5 people, half a day to a day. We found out, okay, there's one user. There's one user who calls who causes that with a lot of invalid, not false, invalid requests. They identified the user. That user was manually removed from the access rights. As a consequence, the product owner decided, let's implement monitoring to see how large that problem is, because they didn't have monitoring until that point, at least not for crawling. About 30 story points. And that was to establish diagnosability. And it showed, there are a lot of crawling attacks, like every day. And every other day you would have someone with above 5,000 requests. Every week or every month, someone with even more. So what they decided then is, okay, well, let's do a temporary solution. We will lock out the crawlers. For that, the business department has to call or to write an email to another business department so they can lock these crawlers. And we have to manually back up the log files, access logs, just to have a legal proof in case that people sue our customer. And that was, of course, until we have a clean solution. The clean solution, clean enough, I would say, is you have an automatic detection already with the monitoring. Now you could do an automatic logging. You have a table, you enter the users, you log them. That's the principle. It's not that high. It's like, I would estimate 30 to 40, 50 story points, something like that. The temporary solution, of course, has interest. That is, with the number of crawlers you have, it's about 1 hour per week the development team spends on manual backup of log files. Then you have a business side that I would say it's about half an hour that they need to log out the crawlers with all the communication that goes on. From May to December, we had 51 cases of that. And I looked into the effort data. This is how the interest evolves. So here's obviously some part of initial implementation, then some reaction. I think this is a manual backup. And then you see more or less a linear increase over time. And now we've already almost reached 30 story points. So that's basically the principle. The principle for building a clean solution. Well, of course, at this point in time, May last year, it would have been difficult for the product owner to prioritize. And because it's only a small overhead every sprint, they still find it difficult to insert or to prioritize that user story. Which quality attributes are affected? Well, it's not maintainability, no problem. Performance a bit, stability, yes, security, but other than that, I mean, the system works fine. I think the interest that you pay is what hurts. You have regular spendings on analyzing outages. The product owner has to do the manual effort for locking out the users. Okay, from our point of view, development team, it's someone else's problem, right? But yeah, it accumulates over time. And of course, you have the opportunity cost, because they do have a payment interface. So people who would like to get the information can buy that interface and can get the information, and then they have to pay. And you lose that. For development, the budget is reduced because you spend tiny amounts per week, but you spend them for securing log files. And of course, for the user, sometimes you have low performance. I had another example, but I skipped that because of the time. So the point is, you don't need domain knowledge to spot that the system is not secured or against crawling. It's a relative widely spread practice. You know what to do against crawling. I think it still falls a bit into design architecture, because that is how you would usually deal with crawling. It falls into the domain debt category because you didn't, when building the system, the domain understanding was not high enough to understand that crawling and the information that the system has is prone to crawling, and crawling can be a problem. And it was probably the people who built the system at that time were not attentive enough to realize that when moving from a decentral to a central use case, that a lot of things would change. Okay, relatively high interest because you have frequent attacks, really frequent. Every day I get these emails. Okay, so again, back to the list. We had these 94 technical debt items. We looked at how they differed in terms of the criticality that was estimated, the principal and interest. There was some difference, but it was not significant. But there is a significant difference in who pays for the technical debt and which quality attributes are affected. For example, for the payers, what you can see is on domain level, it's mostly the product owner, users, operations who pay. It does not often affect development like productivity or maintainability. Documentation debt, interestingly, affects productivity a lot because every time you need to know something, you don't know where to look. You have to ask people. Nobody knows because the product owner walked away, the previous one, and he did. So nobody has the knowledge of the system. 3 minutes. That's what you're going to say, Antonio, right? And looking at effects, domain mostly affects productivity, quality, and use. Code, interestingly, affects all the different levels and aspects more or less equally. And with this, I get to my final slide. I talked about best practices that we collected in specific environment. So they may not be valid everywhere, but in my opinion, what you need to do to stay ahead of your technical debt is you need to make quality a first-level citizen. And that's often a struggle for the best solution. You have to talk with your product owner. You have to fulfill needs of all the stakeholders around difficult things. I could talk for hours, but not today. And for us, technical debt starts where the measurement tools finish. So SonarQube, OWASP are all valuable tools, but we need to have a zero violation policy. So all rules need to be, or all violations need to be fixed. And that's where we start with technical debt management, technical debt backlog. And the zero violation policy, or don't introduce new defects or new violations, is the only thing that works in the long run, because otherwise you will always pile up broken windows. And it is especially valid and valuable in an environment where your product owner will be away in a few years and won't be responsible anymore. And it's not of bad intent, but because they have to fulfill other priorities. And it's crucial to have a technical debt backlog that you then work down either behind the scenes, and best at least without negotiating against features. And higher level technical debt is the thing that is probably more difficult to include, but you also need to include it, otherwise your users will pay, and that's the ones that we don't want to pay. And with that, I finish. Thank you for your attention. I switch back to.
Thank you, Marcus. Great keynote. Thanks a lot. A lot of insightful best practices. Maybe they're context dependent, but I think they still can give like a lot of food for thoughts. Great. So if anyone has questions, please put it in the chat. There is a comment from Justus that I was trying to understand if I understood well. So let's try to see if I can deliver. Justus is saying that technical debt originally was something that we cannot measure with static code analyzer. But today it's not the focus when we talk about technical debt. Instead, we look at SonarQube. Okay, now I understand. So yes, I think you actually went through this. I mean, there is we focus maybe too much into what tools like SonarQube tells us about what technical debt is, while maybe we should focus a bit more on the other ones, like you mentioned about backlogs, having a backlog. So I think I think it was mostly a comment from Justus that is saying, probably he agrees with you, saying that we should focus also on the technical debt that originally was the most important one, the one that is not usually captured by the code static analyzers. I don't know if you want to comment on that while I look at the next question.
Do that. Yes, and exactly that's the point. I mean, these tools help you to have a clean desk. And of course, it's much more difficult to maintain or to have a technical debt backlog, because especially as a researcher, if you look at open source systems, they don't usually have this type of information. So I probably you have to go to industry where, at least if you have a company that is aware of technical debt enough to have this type of debt backlog, then you can start looking into this. This is more difficult, but I think it's much more helpful in the end than just SonarQube measurement.
Yep.
Or CQSE, they're also very good, but
yes, thanks for the answer. And I have another comment by Caroline, and she's asking, yes, technical debt starts after measurement tools finish, and she agrees. So why start with measurement tools? How would you characterize the value of starting with measurement tools? Why should we start with these measurement tools then, if technical debt is basically something else?
Because, okay, if what you have to do is you have to invest into the tools, because SonarQube has, I don't know, 700 rules. Not all of them may make sense in your context. So you have to check all these rules because some of them are like programming philosophy. You have to adapt them. And once you have that, it is a tool to help you get rid of the basic stuff, let's say. You don't have to look manually into that, because SonarQube, OWASP, Security Checker, all these tools will help you detect these things. So you can free your mind from these low-level stuff have, as I said, a clean desk, and then you can start and concentrate on the more important stuff. And that's I think this is a great value, because it also helps to establish quality goals with your product owner or the customer. The definition of done, to have 0 violations, then there's no discussion.
Yeah, thanks, Marcus. We have one more question. So the question is, I'm interested to know how the effort data, story points, were recorded in the first place. Was it based on expert opinion, or did the developers do a rough estimate when they were working on similar items previously? Which I find it's interesting. Yeah.
It's both, but what we do is a clear estimation. So we break it down into tasks. Each task gets a person day amount. So we have a precise estimation of the effort that this user story is going to take. Of course, all estimations are wrong, but you have a quality, but we're quite good, at least on average. And that gets converted into story points. And the reason for that is a commercial one, because our customer pays us by the number of story points or t-shirts that we do in a sprint. And that's also why we have to make sure that it's a good estimation. It shouldn't be too high, because that in the long run will lose your trust with your customer. And if it's too low, well, you don't make money and you're going bankrupt anyway. So that's why that's a good question, because depending on your context, it's just like, say, a scrum poker. But in our case, the story points really reflect the effort, because we do a detailed estimation beforehand.
Okay, great. We have one more question by Marion. Have you any insights on how to bring companies to make software quality a no discussion topic? Can you do that?
You will always have some discussion, especially with the more expensive ones. And of course, it depends on context. I mean, our system, we work for other customers, and now with an agile mode, less framework in that case, they insist of having a definition of done. And then it's easy to get this inserted as, we have to have 0 violations, we have to have quality, and it's no question that you do need to do some refactoring from time to time, or even regularly. If you have larger items, you will always get into the discussion. Like this example, right? We said, okay, let's build it right now, the clean solution, but then you have to have deadlines, and the budget is slow, and then you have to do scoping. So you will have some discussion, but I think if you convince your product owner that it's worthwhile, then they will go with you. I don't know about the time. Where is it?
2 minutes.
Okay. One example we had like 8 years ago. Our product owner had so much feature pressure that they wanted to cut out of the quality phase at the end of a release. We advised against that, but there was political pressure. So we said, okay, but at your responsibility, you will pay afterwards. We're convinced of that. We did that. We built features until the very last day, and the release afterwards was the first release where we had to do, I think, 7 redeployments, bug fixes, which were high political issues. So the product owner learned to listen to us, because when we say it's really a problem and you will pay afterwards, then it's true. It's a culture thing, and you have to build trust. That's also part of the truth.
Yeah. Great. Thanks a lot again. Only 1 minute left. I don't see other questions. So I have one quick question for you. When you talked about this transition project, right, where you built all this backlog, right? How long did it take? I mean, roughly.
The transition phase was 6 weeks. So I think 3 weeks for building the deck, the list, and then we had a lot of other knowledge transfer sessions. So it was the building the list was only part of that.
Yeah, I have a lot of other questions, but the time is actually up. So thanks a lot, Marcus. Again, this was great keynote, great insights. we have another we can continue the discussion in the discussion room that Zadia has just posted. So if you want, after this, there is like 10 minutes break, we can continue the discussion. Otherwise, thanks everyone, and see you for the next sessions of TechDebt today. Bye.
Thank you. Bye.